All right, let's do problem 65 on page 349. And when I first looked at this problem, it kind of threw me off. But I think I got it figured out now. So let's read problem 65. And let's see, there it is down at the bottom. It says a fish finder uses a sonar device that sends 20,000 hertz sound pulses downward from the bottom of the boat and then detects echoes. If the maximum depth for which it is designed to work is 200 meters, then what is the minimum time between pulses in fresh water? Okay. So let's see. This is for okay. So let's do that. Now, what really got me is I thought I was supposed to use that 20,000 hertz, and but it turns out to be that's kind of a red herring almost. Zoom out a little bit. So let's write down what's given. So here's the top of the water, and here's maybe the bottom of the pond or lake or whatever you're doing. And so here's the boat. I'll put a sail on it just to make it look like a boat. And it's got a depth finder, and it sends out a pulse. Now these 20,000 hertz, it's just like it just sends out a bunch of little waves, and they really kind of go as a pulse. And so they go down, and then they bounce off the bottom of the water, and then the pulse comes back up and reaches the top. And it was given that this is 200 meters from here to here. That's the maximum it can go. So what you have to do is leave enough time for the pulse to go down and back before you send the next pulse. So you send a pulse of sound, goes through the water, maybe hits fish, and then or it hits the bottom, and then that pulse comes back up, and then you read the echoes, and then you have a computer or something that can figure out what it is that's going on. So now one of the things you have to do, it said it's fresh water. And the speed of sound in fresh water, well, you have a table in the book on page 323. There it is. And in water, not seawater, but just like fresh water, it's 1,440 meters per second. So even though I had to look it up, it's still considered given. And so what are we trying to find? We want to find the period of the time between pulses, and I'm going to call that the period. So you want to send out the next pulse immediately after you get the echoes back. So let's solve it. Now we know that the speed of sound is equal to the well, we could say the frequency times the wavelength, but that doesn't really help. But we know that the frequency is 1 over the period, so that would be the wavelength over the period. Now, what threw me off is I was trying to use the 20,000 hertz of this, and I was going 1 over 20,000, this tiny little number, and it just wasn't making sense. And then I realized that you want the period between pulses of 20,000 hertz sound. So I don't know, it's kind of a poorly written problem in a way. So now we can solve for the period. The period is equal to the wavelength. Maybe I should put the wavelength in quotes, divided by the speed. Really, this is the distance the wave has to travel. And so that pulse has to travel down and back up. So really, this is 2 times the depth. And then we know what the speed is 1,440 meters per second. This cancels that out. And then we get seconds. And so I get my calculator. It's 2 times 200 is 400. So I have 400 divided by 1,440 equals, and you get 2.7777, an infinite number of sevens. I'm just going to call it 2.8. I'm sorry, not 2.8. 0.28. It's times 10 to the negative 1. 2.77 times 10 to the negative 1. So it's 0.28 seconds. I think in the back of the book it says 0.3. They're sticking with one significant figure because this value, the depth was given to one significant figure. So I guess they're trying to stay consistent with that. But I don't know. That seems a little ridiculous to round this off to the nearest 100 meters. That seems silly to me. So I'll just keep two significant figures. I'll assume that this is at least 2, maybe 3. So you could call it 0.278 if you wanted it to 3 significant figures. And so if you want to send out a pulse of sound and you want it to have, be able to go all the way to 200 meters and hear that echo, you need to wait at least about 0.3 seconds before you send the next pulse down. You don't want those pulses interfering with each other. Anyway, that's how I did it. Any questions? Okay. That is all.